let's find the inflection points and use the points to analyze the concavity of this function. So we will go by this procedure, finding f prime, f double prime, because double prime is for concavity, and then the single prime is for slope. Slope leads you to the relative minimum and maximum. And then using the second derivative, find the critical number, build a test interval, test each interval, and then we draw our conclusion. Okay, for the domain of the given function, do we need to worry about the domain? The answer is yes/no. The reason I say yes is because the domain affects the test interval. But in this problem, we have a fourth degree polynomial, so that means x can be any value you want, any positive, 0, or any negatives, right? So it doesn't matter what value you choose for x, the function is always defined. Okay, first prime. So this is a 12, right? So this is a 12x to the third. And then minus also 12, x squared, the derivative of 2 is equals to 0. We don't set this equals to 0 now because setting that equals to 0 is for relative min and max. And then another prime, bring the 3 down, so you have 36x squared minus 24x. And then now you set this equals to 0 to find critical numbers, right? Because the second derivative is about concavity. And then how about factor? Factor our 12x, and then we have 3x minus 2 equals to 0. So using 0 product property, so let me say this one more time. When you use 0 product property, the other side must be 0. If the right hand side is 1 or anything non-zero, then you cannot use 0 product property. Just a basic algebra question. Okay, so 12x equals to 0, then x is equals to 0, and then 3x minus 2 equals to 0, then x is equals to 2/3, right? So they are my critical numbers. And then you use these critical numbers to build your test intervals. So you have one number line, and then you drop the numbers on the number line. So this is a 2/3, so one line to cut. So you just cut the line into 3 pieces. The first piece is from negative infinity to 0, and then from 0 to 2/3, and then from 2/3 to positive infinity. All right, and then we have to test each of the intervals, so using a Sine chart. So this one to give you a better color contrast, so let's do this in a different color. So I am going to write down my test intervals. Actually, I'm going to move a little bit to the left. So my test intervals. So this is my first row, and then we make a chart, make a table. And then we have from negative infinity to 0. And then the next one is from 0 to 2/3. And then the next one is from 2/3 to positive infinity. So 2/3 to positive infinity. And then the next one is your test value. So test value. And then you have to pick a number within each interval. When I pick numbers, I prefer to pick easy numbers like x equals to -1, right? So let's say x equals to 1/3, and then x equals to that is less than 1. So how about we pick 1? So the last one, if you ask me, can you pick x equals to 105? Can you pick x equals to 111? That is fine as long as the test number is inside the interval. If you pick big numbers, then you have a lot of arithmetic to do when you test the numbers, right? And then you have to test f double prime of the value that you selected. So f double prime of -1, and then f double prime of 1/3, and then f double prime of 1. So f double prime of 1, that gives you a 12. This gives you a -4. This gives you a 60. So 60, I don't care if that is a 60, 59, 61, or 39. As long as that is positive, then I got what I wanted to know. So this is negative, and then this is positive. I don't really care what that equals to. All I need is positive or negative, because positive means concave up. So the last row is conclusion. Positive double prime means the function is concave up in that interval. Negative means concave down. And then positive means concave up. So you have up, down, and up. Concave up, concave up, concave down, and then concave up. So when you go from concave up to concave down, so there is an inflection, right? So let's just put this in a different color so that gives you a good comparison. So inflection point, and here is another inflection point. At where? At x equals to 0 and x equals to 2/3. So we found two inflection points. And then the last question that the book usually asks is, can you tell me the exact location, the coordinate of the inflection? So at this point, we have other than that, the concavity. They might ask you to write this concave up. They will ask you to write an interval. So concave up, then that will be from negative infinity to 0, and then from 2/3 to positive infinity. And then concave down, so that will be from 0 to 2/3. When you find the exact location of the inflection point, then you will have to plug it into the given function, which is f. So f of 0, so that is 3 times 0 to the 4th minus 4, and then 0 to the 3rd plus 2, so that is equals to 1. And then the first inflection point is 0, 1. And then the other point is f of 2/3. So that is equals to 3 times 2/3 to the 4th minus 4 times 2/3 to the 3rd plus 2. So this one, I got a 38 over 28 over 38, not 28, 38 over 27. So 2/3, 38 over 27 is another inflection point. Oh, by the way, very important, when you do this kind of works online, I don't think they accept decimals. You have to give out the fraction. So if you are lazy, you don't want to go over the common denominator, so here is one thing that you can do. So let me pull this picture up. We have a graph, and then we have so the way I do this is I type this on my graphing calculator. So I plug in the 2/3, and then once you press enter, you get a decimal, right? 1.407 something. Usually online, when you do works online, they don't accept decimals. So if you are lazy, you don't want to work with the common denominator thing, so all you have to do is you press the math key. So there is a math key on your graphing calculator right underneath the alpha key. And then once you press the alpha key, you have to select the fraction, the first item on the menu, on the math menu, fraction. And then you will see this answer convert these to fractions. So convert your answer to fraction, and then they will convert the decimal to a fraction for you, so you don't need to do the common denominator by yourself. And then the picture, so let's take a look at the picture. So this is concave up from negative infinity all the way to 0, right? So that is right over here. Here. I'm glad that I have the graph. Look. 0 plus 2, 2. I'm sure you already found this mistake. So 0, 2. This color is visible. So from 0 to 2, so this is concave up. And then from 0 to 2/3 is about 0.67. So which is right over here. So we have a little bit of concave down. The previous dot is too big. So here from 0 to 2. So this is concave up, and then from this to 2/3, and then this is concave down up around right here. So we have a little bit of concave down. And then from 2/3 all the way to positive infinity, and then the rest, they are all concave up. So that's what the graph looks like. All right, so that is the end of this video. I'm glad that I found the mistake, the 0 plus 2 equals to 2. If you think my instruction is clear and helpful, give me a like. Share the video in any social media for me, like Facebook. If you are new to the channel, please spend 2 seconds to click the subscribe button down below. I appreciate your help really, really much. I will see you all in the next one. Signing out.